Alright, so guys, for this lesson here, I want to just remind us of our general strategy. Okay? Get the equation in terms of one trig function if possible. Get that trig function by itself if you're dealing with a linear, or solve it as a polynomial if you have a polynomial or quadratic type. Okay, you might get it set it equal to 0. In some cases, you might want to get it by itself and then square root both sides. Alright, but then finally you're going to use inverse trig functions to find the answers. Okay, now we've been doing a lot of these where you could just use the unit circle. We won't always be doing ones where you have to use the unit circle, but if you could do it with the unit circle, then when you're allowed to use a calculator, it should be a piece of cake. Alright, so let's take a look at a couple of other cases that you might run into of types of equations to solve. Alright, first of all, we have trig equations in these polynomial forms. Alright, the last one from the previous IP, they gave you a cosine times cosine minus 1 equals 0. That had come from a polynomial form. Well, here we have ones kind of similar. And you'll see here we have 2 sine squared x minus sine of x minus 1 equals 0. Alright, you can solve this the same way you would 2y squared minus y minus 1 equals 0. Okay? The only difference is instead of y's, we have sines of x. Okay, so there's going to be an additional step at the end using that inverse trig function. Okay? But the first thing we want to do here is figure out what sine equals. Okay? So since this is polynomial, I'm going to factor it. Okay? And I'm going to have something sine of x, something sine of x. The only way I can factor that minus 1 is to do a plus 1 minus 1. Okay? I need a 2 in front of the first sign.
-2.
Not a negative. Okay? Because if I do this, it'll be positive 2 times a negative 1. We'll make it a negative 2 sign. And then this will be a plus 1 sign. Negative 2 plus 1 is a negative 1 in the middle. Okay? So you're factoring it just like you would a polynomial with x's or y's. We just happen to have signs in here. So now, don't forget your zero product property, it was called. When you have two things multiplied together that equal 0, then either the one factor has to equal 0, or the other factor has to equal 0. Okay? So sine has to be a negative 1/2, or sine has to equal 1. Okay? Does everyone follow this? Okay? Now, where does sine equal a negative 1/2?
Pi over 6 and 5 pi over 6.
No, pi over 7.
Wait,
Oh,
11 pi over 6.
You got the right reference angle, so it's going to be 11 pi over 6.
And pi over 7. Oh, my bad. 7
And
pi over 6.
there you go. I know what you meant. 7 pi over 6. So we've got third and fourth quadrants here. Okay? The third quadrant, 7 pi over 6. Fourth quadrant, 11 pi over 6. Those are the two quadrants where sine is negative. Okay? How about when sine is equal to 1?
Pi over 2.
And pi over 2.
Good. Pi over 2. In that case, we only have one solution, because it's a quadrantal angle, so that happens. Okay?
It's funny for quadranting.
Alright. Are we good with that one? Does that make sense? Alright. Now, here's another case. This is where we start to be using our identities. Okay? This is where these get fun.
Just use the quadratic formula.
Use what?
The quadratic formula.
Well, we could use the quadratic formula, but not yet. Because notice this one has a sine squared and a cosine. It's like we have the equation 2y squared plus 3z minus 3 equals 0.
Then you could do
We have two different unknowns here.
then you change the sine squared to cosine squared plus 1 minus 1. I bet 1 minus cosine squared.
There we go, good.
Beautiful.
This is where the identity comes into play. We can get it all in terms of cosines if we use that Pythagorean identity, 2 times 1 minus cosine squared
What? What did you do?
instead of a 2 sine squared. Okay? Okay? Is everyone with me there? So, we have to distribute the 2, and we have a 2 minus a 3, that's a negative 1. Okay? We have 2 times a negative cosine squared, so that's a minus 2 cosine squared plus 3x, 3 cosine x, sorry. Okay? Now everything's in terms of the same unknown. We have that same cosine of x that we're trying to figure out. Okay? Now, whether you choose to do factoring or the quadratic formula is kind of up to you. This one actually can be factored. If we had a negative 2 cosine and we have a negative cosine, or I'm sorry, I should say a positive cosine. And then if we put the minus 1 here and the plus 1 here to get our negative 1, this will give us, so when I do the outers, a positive 2 cosine and a positive 1 cosine. So that gives me my 3 cosine of x in the middle. Okay? Be careful with this part. But that's how we could figure that out. So now we have the zero product property. What would cosine equal from this first set of parentheses?
1/2.
Positive 1/2. Okay, good. Negative 1 over negative 2. X is, cosine of x is 1/2.
So that would be
Okay.
at,
So what is x here?
pi over 3 and 5 pi over 3.
Good. Pi over 3. And we need fourth quadrant because cosine is positive, so that's also 5 pi over 3. Okay? Okay. Then we have our other possibility from this. You're right, cosine of x has to equal 1. So x would equal what?
0 pi.
Or 360.
0. Or you could do 2 pi. One thing to note on some of them, they had it written like this, 0 to 2 pi, and they'd put a parenthesis there, so you wouldn't have to put the 2 pi there. Okay, in fact 2 pi would technically be out of that range. Okay, so just be aware of that. Okay, but you see here, we've got pi over 3, 5 pi over 3, and 0 for 3 answers here. Okay? So, we've run into ones where we have a quadratic form. We've run into ones like this where we have two different trig functions. Alright?
The new one?
Okay. Here's another one.
Yeah.
When you don't need to get it all in terms of one trig function, or maybe can't. Okay? Now, I want to see what you guys come up with on this one. We have cotangent of x times cosine squared of x equals 2 cotangent of x. What would you guys propose we do for this one?
Change
Always
the
divide
cotangents
it.
to cosine over sine.
You could.
Wait,
What
divide-
else?
Can we divide
How we
the
just do?
code on both
Oh,
sides?
that's smart.
Okay, so we could do something like this.
It's a good idea.
Now, is that okay?
Algebra, well, no, it's algebra, you can't do algebra unless you don't,
Well, no, you're allowed, these are equations, we know they're equal,
okay.
okay?
Yes,
Let me ask you this, if I had x times x squared equals 2x, so when I'm solving that, am I allowed to divide by x?
Yeah?
Yeah.
Yeah.
Yes.
Who said
Yeah.
no? Why not?
Because we don't know the x.
We don't know the x, and the x
Oh.
might be,
Zero.
Maybe zero.
Can be maybe two.
x might be 0, which would make this illegal, right?
Yeah.
Also,
But I think
what did we just do to the degree of our equation?
You just changed it from x cubed to.
We just changed it from a cubic to a quadratic, and we just lost one of our roots. We just lost an answer. Now, if you divide by cotangent, you will get some possibilities, but you're going to lose some of your possibilities too. Okay? So, we don't want to. I was hoping someone would say that. Okay?
You got it.
So good. That was a good wrong answer, alright? Because that helps us learn, alright? And tie things back to other things we already know. So we don't want to divide by cotangent. So in this case,
Oh,
what do you think?
I was gonna say convert cotangent into cosine over
Yeah.
sine.
That is possible, okay? The thing with that is we're still going to have some signs. The only way to get rid of them would be to multiply by sign, and then you're kind of doing the same stuff. So, watch this. What I'm going to do is I'm going to take cotangent of x, cosine squared of x. I'm going to subtract the 2 cotangent of x over to this side. Now do you see what we can do?
Negative cotangent, yeah.
And like they all have cotangents. So.
They both have cotangents. So I could factor this out. Cotangent of x equals cosine squared x minus 2. And that equals 0. Okay? So, either cotangent equals 0 or cosine squared of x equals 2.
So how'd you go from? How'd you get rid of the cotangent? Oh, we just.
I didn't get rid of it, I just
distributed.
factored it out.
So
Yeah,
just-
distributive property, we factor that out. Okay?
So simple.
So,
So elegant.
what would x be if cotangent of x equaled 0?
I think
Cosine has to be positive.
What?
All students take
0.
pi over 4 and 5 pi over
0
4.
pi.
Hang on.
So it's 0.
If cotangent of x is 0, what has to equal 0?
Cosine.
Cosine would have to be 0.
Shoot, oh, cotangent, not tangent. Then it's pi over 2 or 3 pi over 2.
Oh.
So you have x equal to pi over 2 or 3 pi over 2, okay? Alright? This is a little tricky, okay? We gotta be careful with it, okay? Now, if cosine squared of x equals 2, that means cosine of x equals square root of 2, so plus or minus 1.414, right? You guys know square root of 2?
Yeah, of course, yeah.
Of course. Okay?
Yeah.
Now, where does cosine equal 1.414?
Oh, at pi over 4 or something like that? No,
No,
I'm just kidding.
it equals root 2 over 2 at pi over 4.
I was
Pi
trying.
over 4.
We need to use our
Something special?
Try it. Go ahead, try it on your calculator.
Well, wait.
Inverse cosine of 1.414.
1.4.
Hmm?
Isn't that the same as pi?
Doesn't have an answer.
Isn't that the same?
It doesn't have an answer.
It's an error.
It says an error. Why does it have an error?
Oh, it's gonna be zero.
Huh?
Zero. It's gonna be zero. Sine is zero.
No.
Wait, does like square root of 3 over 2 equal 1.414?
Well, square root of 2 is 1.414, yeah.
What am I saying?
Okay. Think, guys. What do we know about cosine?
Give up.
Because of the 45 degree is
Cosines make you hate yourself.
root 2 over 2. If we can just times 2, it's become 90 degree. 90 degree we know cosine should be 0.
Okay, yeah, so that strategy, that's not a bad idea, you know, hey, if cosine of pi over 4 is root 2 over 2, can I just double it? And he just proved that we can't, alright, because we know the cosine of 90 is 0, okay, not 2. What's the graph of cosine look like?
Pi over 2, so pi.
Yeah, you got those points, where does it start?
Oh, 1.
At 1, and well, how far down does it go?
-1, so it's out of range.
It's out of range, okay? There are no solutions. There's no angle that is going to give you a cosine bigger than 1 or smaller than -1. Okay? So guess what? This whole side is worthless.
Whoa.
The only two answers we've got are right here. And guys, this is why it's important not to divide by the cotangent. If we had divided by cotangent, we would have gotten rid of the only answers that actually existed. Okay? Alright, so that's what we've got with that one. Okay? So, we try to get everything in terms of one trig function, if possible. Sometimes it's not always possible, though. Okay? So you just have to do the best you can. Try to look for cases like this where you could factor it out. Okay? Alright, here's one other case. When you can't get it all in terms of one trig function very easily. Okay? Notice, we know how cosine and sine are related. I mean, they're related if we divide them, we've got a tangent. If we have them squared, then sine squared plus cosine squared is 1. The problem is here, neither of them are squared. Okay? So,
Maybe just spread the whole thing.
this is an equation.
That's not a bad idea.
So, what'd you say?
Just spread the whole thing.
Square the whole thing. This is an equation. So, those of you who were wanting to do this all the time when we were doing proofs, now you can. Okay? Now, we can go ahead and square both sides. Okay? Now, so, one thing to remember when we are squaring both sides, on the left side we have a binomial that we're squaring. So, what do we need to do? To square a binomial,
Plus or minus? Oh, no, never. We just FOIL.
FOIL. FOIL. Don't forget to FOIL. Cosine squared x plus 2 cosine x plus 1 equals sine squared. Okay? Don't forget to FOIL. Now that we have cosine squareds and sine squareds, now we can get everything in terms of one trig function. Okay? How would I do that?
Maybe subtract to the side
One.
first side.
Huh?
Sine squared x.
You can get.
Okay, we could do that. We have cosine squared plus 2 cosine x plus 1 minus sine squared x equals 0.
Make it 1 minus.
You can make sine square x become 1 minus sine squared x.
Sine squared x is
1 minus cosine square x.
1 minus cosine squared x. Okay? Or you could even see it here, a 1 minus the sine squared x is cosine squared x. Okay? However you choose to plug it in is fine either way. Alright, so cosine squared x plus 2 cosine x plus a cosine squared x. Notice now everything's in terms of cosines. Okay? Now, before we move further, why would I change the sine squared into a cosine squared instead of changing the cosine squared into the sine squared?
Because you don't have the square.
Alright, yeah, good. We have that cosine of x that we can't change into a sine. At least not very easily.
Let's just square it.
Alright? So, it's much easier to put everything in terms of cosine since we had a cosine to the first than it is to try to make that a sine and then somehow make this into a sine. Okay? So, now we have everything in terms of cosine. We have 2 cosine squared x plus 2 cosine x equals 0. We're back to this polynomial form, so we look to factor.
Yeah, we divide by cosines.
Two cosines equal to 0.
Yeah, we're going to take out a 2 cosine of x, and we have a cosine of x plus 1 in the parentheses. So either cosine is 0, or 2 cosine is 0, but that just means cosine is 0, or cosine is negative 1. Okay? So where is cosine negative 1?
It's gonna be
Pi.
At pi. At pi. And where is cosine equal to 0?
Pi over 2, 3 pi over 2.
There we go. Now, so there's 3 solutions. This problem, anytime you do what we did here, you have to be careful, you have to check. Alright? Why do I have to check my answers at the end on this one?
Had a mistake somewhere.
Because we squared both sides. We changed the degree of the problem by doing that. It was just like when you had those square root equations, the radical equations, you had to undo the radical by squaring. You had to check your answers for extraneous roots. Okay? Extraneous roots.
That's going way back.
It is, but this all ties together, okay? Math is not a series of these disjointed topics. They're all connected. Okay?
The one that you like tested for them.
So, we're looking for extra roots. Roots that are roots of the equation we ended up with, but aren't necessarily roots of the original equation we started with. So this is where we have to plug it in, okay? So we're going to test cosine of pi over 2 plus 1 and see if that equals sine of pi over 2. What's cosine of pi over 2?
0.
Okay. 0 plus 1. What's sine of pi over 2?
1.
1. So those are equal, so I know that that is a solution to our equation. Okay? So now we'll try 3 pi over 2. Cosine of 3 pi over 2
0.
plus 1. Okay, we have 0 plus 1.
Negative 1.
And then we have sine of 3 pi over 2. What does that equal?
Negative 1.
Okay, that's negative 1. Are those equal? No. Alright, so I know that that is an extraneous root. And then finally, we would try pi.
Negative 1.
What's cosine of pi?
Negative 1.
Negative 1. Okay, what's sine of pi?
0.
Are those equal?
Yep.
Yeah.
Yes. Alright, so our solutions are pi over 2 and pi. Anytime you change the degree of the problem, you've got to check for those extraneous roots. Okay? Questions?